Two water tanks hold 28.62 gallons and 31.2 gallons of water. The larger tank is leaking at a rate of 12 hundredths of a gallon per hour. The smaller tank is leaking at a rate of 8 hundredths of a gallon per hour. After how many hours will there be less water in the larger tank than the smaller tank? All right, so let's draw a picture, both because it will make it easier to understand this problem and also because I know everybody loves my art. I'm going to assume these are cylindrical tanks. The problem doesn't say they're cylinders, but let's just go ahead and assume we're going to call this the small tank, and it's got 28.62 gallons. And then we've got the very slightly larger tank. Doesn't hold way more. It's got 31.2 gallons. And the larger tank is leaking water. It sprung a leak down here. It's leaking water at a rate of 0.12 gallons per hour. And the smaller tank also sprung a leak. What are the odds? Two leaky tanks, 0.08 gallons per hour. So the large tank has more in it, but it's leaking faster. So eventually the large tank will have less in it because it's leaking faster. So the question is, after how many hours will there be less water in the tank, the large tank, than the smaller one? Okay, so here are our two variables. After how many hours? So let's not use x and y. Let's use h for hours, and let's use g for gallons. We don't have to use x and y. Nobody tells us what to do. So let's write our two equations. So small tank has 28.62. That's our starting amount or our initial amount. And we are losing, so minus 0.08 gallons per hour. Large tank, let's do that one in green. Large tank has 31.2 gallons in it, and it is losing 0.12 gallons per hour. And the question is, after how many hours will there be less in the large tank? So the large tank is over here um, on the right side. So after how many hours will the large tank have less than the small tank? Another way of saying that is, when will the small tank have more than the large tank? When will the large tank be lower is the same thing as asking when will the small tank be more. If it bothers you the way I wrote that, you could flip it. 31.2 minus 0.12h is less than 28.62 minus 0.08h. If you want to use the less than symbol and write it exactly the way it's written in the problem. But these are the exact same thing. So I don't love that this problem has so many decimals in it. And of course, we've got a strategy for getting rid of the decimals, which is to multiply by a factor of 10. It looks like the most number of spots we will have to move any decimal is 2. The 28.62 and the 0.08 and the 0.12. If we move the decimal 2 times, we will have no more decimals. So let's multiply everything by 100. That will get rid of all of our decimals. So we do 28.62 times 100 minus 0.08h times 100. And then we'll do 31.2 times 100 minus 0.12h times 100. Multiplying decimals by a factor of 10 is just so easy because all you do is just move the decimal point two spots over. So 28.62 becomes 2862. 0.08 becomes 8. 31.2 becomes 3120. And negative or minus 0.12h becomes just 12h. Okay, so now we're just solving a regular inequality. Anytime we have variables on both sides of the inequality, like we do here, our goal should be, of course, to get them on the same side. So let's start off by adding 12h. Adding 12h is a good plan because it will not only get our variables on the same side, but it will make sure that we have a positive h, which is good. Having a positive variable is very, what's the opposite of negative? Very, very good thing. Let's subtract 2862 on both sides so that we get our constant by itself. Oh my gosh, what is this going to be? Okay, so it's going to be 8. I'm really good at subtraction, you guys. 258. Sure. Okay, and then we will divide by 4. My kingdom for a calculator. So that's gonna be what is that? This oops, what in the world just happened? Okay, so that's gonna be let's see, 6, 4.5, 64.5. Does that sound right? Sure, 64.5. So what does that mean? I forgot. What was H? Oh yeah, hours. So after 64 and a half hours, the large tank will have less water than the small tank. There we go. 64 and a half hours, assuming that I divided and subtracted and stuff correctly, which, there's like a 40% chance I did. So probably 64.5 hours. You should probably go ahead and check me. And if I did it wrong, whatever you do, don't tell me.